Okay, I assume that many, if not all of you, have heard of sumo bots. It's a robot wrestling on a 4-foot or 3-foot diameter circle. And the question today, so I did a sumo bot league about a year ago. I think it was before COVID. Yeah, it was before COVID. And one of the things that I realized that would be really useful to know is if your wheels are slipping and you're moving in some direction other than what you expect to be moving, how could you detect that? You know, your wheels, even if your wheels are slipping, you don't know if you're slowly making forward progress, pushing your opponent, or you're making backward progress with your wheels slipping. And so I really thought it'd be useful to know, you know, which way is my robot being pushed, and should I try backing up, continue pushing? Okay, that's a reasonable thought.
You could tell if you're going sideways.
Okay, any other thoughts?
You have to double integrate, which makes them a little bit noisy. First integration gives you speed, second position.
You're talking about the accelerometer?
Yeah.
Yep.
They're generally better for higher speed, sharper motions like a golf swing or a javelin throw or those kind of those kind of events.
Okay.
If you ever want one to play with, I've got a 9-axis one which has a compass in it too.
So no other ideas besides accelerometer?
No, I got an idea. I just had to flush out my mouth there.
All right.
So if you can determine that how fast your motors are going.
Okay.
If you have what do you call it?
Encoders on the motors.
An encoder or something, or Hall effect or something like that going on the motor. You should be able, and then you have another sensor that is watching the ground go by, so to speak. And some mathematics between those two should be able to tell you whether or not you're going forward, going backwards, or what.
What kind of a sensor can see the ground going by?
Yeah, a mouse, an optical mouse.
Okay.
If you put an optical mouse looking down, they are moderately good at being able to find out where you are.
Okay. Yeah,
I mean, the math may, it may be jumping around so much that you're not going to get really good math, but in and of itself, that's going to tell you something.
Okay. Yeah, I mean, so a mouse on the proper surface does a pretty good job of keeping track of where it is. And these, I don't know if you saw
it should do good on the black mat.
The black mat board?
On the black sumo bot.
Painted, yep.
They get lost on anything that's really, really too white.
Okay. What about a mechanical mouse?
Yeah, good unless somebody hits and starts knocking you around. Well, even the optical mouse would be difficult to be knocked around. But yeah, you could have an optical mouse with a ball on the end of it.
Just got to keep the ball clean. And those,
I always keep my ball clean.
and the boards sometimes aren't as smooth as you would like.
Right.
You could also do, if you're just wanting forward and reverse, and when you're pushing against something, you could do stall detection with your motors, monitoring motor current.
Well, not if they're slipping.
Well, if they're slipping, then the motor current will go down.
That's right. But you don't, if you're going forward, you see the current go up because you're stalling the motors, and then the current goes down and the speed of the motors goes up, you can assume that you're either going forward or you're slipping.
If your
but if you're
current
slipping,
is the same as it was before it went up, then you're moving. If it's lower than it was before you stalled, then you're slipping.
Okay, but you don't know if you're going forward or backward at that point.
Yeah, if they're slipping, you can assume someone is, well, no, you can't tell if you're stuck in place and pushing or if you're being pushed backwards.
Yeah.
You need an accelerometer for that.
Yeah. Or if, you could be making progress, but your wheels are spinning.
Yes, you could be making slow progress.
So maybe it makes sense to slow down the motor to recapture your static friction or whatever, the grip of the tires. But if you're being pushed backwards, you probably don't want to slow down. Well, maybe you do. I don't know.
I mean, you could get a LiDAR. There are some nice LiDAR things, but that's just a rabbit hole to go down.
There's probably a robot in your face. So you may or may not have visibility forward.
Yeah, but
and there's probably kids running around outside the dojo, and I don't know.
Yeah, it's sort of a rabbit hole. I mean, they're trying to use that with cars, they have the same rabbit hole with kids running around, etc.
You could try to do something with a camera. There's a nice white ring around the edges of the ring that's of known dimension. So you can probably figure out where you are inside that ring with a picture. Take a couple of those and figure out which way you're moving.
Does the camera have to be on the device?
Yes, you can't talk to the robot while it's competing. Right? It's not like you can control it with a transmitter or anything. It has to be autonomous.
I wonder if there's a way to do this with infrared sensor.
Looking which direction?
Well, down.
Well, that's what mice use, right?
Yep.
Yeah.
So an optical mouse is an infrared sensor looking downward.
Even if you had one on, assuming you could either have 3 or 4. So if you have a rectangle robot, you could have 4. If you have a round one, you could probably do it 3 and look at the distance from walls or whatnot. That may not work if you don't actually have anything close enough.
There's a whole bunch of kids lined up all around the circle. And they're yelling and screaming and moving.
The optical mouse does essentially a gradient operator, and that's the deepest, simplest, cleanest way out of it.
Okay.
I think if you're going to use optical mouse, you need to use a full inertial chip with the gyro in it, because if you get bumped in to a yaw where you turn, your X and Y is no longer valid on there. So it'll tell you which that you not only have dispersed in space, but you've also had some
rotation
degree of yaw.
I mean,
You know,
Most SumoBots have no clue where they are in the ring, right? They have sensors on the corners that look for the white ring around the edge so that they don't drive off the edge. Normally you run until you see white and then you turn randomly right or left and run, and you're trying to bump into your opponent at some point and start pushing them. So I don't think that translating is going to be an issue. You mostly just want to know, am I pushing or am I being pushed?
now, doesn't a PID controller actually compensate for some of this in within the PID controller itself? So, I mean, if you have a sophisticated enough motor controller, you may be able to know what's going on.
Only if your wheels don't slip. As soon as your wheels are slipping, you have no idea whether you're being pushed forward, backwards, sideways.
Okay, so are all your wheels going to start slipping at the same time? Probably not. Whether or not a PID controller can detect that phenomenon, I don't know.
Aren't they connected together?
Well, no, PID controller is controlling each wheel individually.
Yeah, but I mean, this device, does he have independent motors?
Yeah, well, that does
ones
matter.
I've done have used two motors, one for each wheel.
If you have two optical mice, then you can pick up rotation. You can pick up your yaw. If you have two optical mice looking down, there's a one, I think there's a degree of freedom you might miss, but basically, if you have a differential movement between one or the other side, then you know you've got a rotation. The second thing is that there are a number of new materials which basically behave like gecko's feet, and they stick to a surface. And you could coat the wheels in that kind of stuff, and that would make it. I don't know whether it's considered cheating, but
there are different classes, right? The one I was in, you had to use Lego pieces. And so coating it with gecko goop would be illegal. But they also had an unlimited class where you can do anything you want as long as you fit within a starting volume. Yeah, there have been big studies about the coefficient of friction of all the Lego wheels that have ever been made and all the kits they've ever sold and the tracks and the rubber ones from the 60s and 70s and just amazing amount of research into those wheels for getting your best advantage in SumoBot. All right, any other ideas? Okay. So how many people have show and tell tonight for after my presentation?
I've probably got something I can do.
Okay. Any other people want to? Okay. So let me share again. All right, can everybody see that?
Yep.
So my daughter said, can you make a device that would monitor the temperature in the refrigerator at where she works and lets her know if it gets warm? The door sometimes sticks open, and so she would love it if when the door didn't close fully and the vaccines that were in the refrigerator start warming up, that she could get a little message on her phone that says, go check the door. And so this seems like a pretty simple device. You know, forever, you check the temperature. If it's too hot, you send a notice to the cell phone. And then you delay a little bit and you do it again. So my go-to sensor is the Dallas Semiconductor one-wire
Yeah, I got those.
device. You know, you can get 10 of them for $10 at Amazon. You can get 10 of them for $47 at DigiKey. And Adafruit has Arduino code. And so the next part is, well, how can we send a notice to a cell phone? She has an iPhone, so that's what I looked at. There's some services that will send text messages to iPhones and other phones, like Twilio and Cinch. She's on Verizon, so if you can figure out how to send an email to her phone number at vtex.com or my phone number at vtex.com, we'll get message on the iPhone. If This Then That has an iOS app. I have that on my phone. I have a thing set up that it monitors one of my feeds on Adafruit, and if it sees that the power is out at the barn, it's supposed to notify me. It has never worked. If you pay more, I get the free version of If This Then That. If you pay more, they say that they poll more frequently. And so evidently there's some kind of a polling delay. And if you're trying to find something that happens briefly, or that happened, even if it doesn't happen briefly, you know, there may be half an hour to an hour delay using If This Then That. If you go to the App Store and look for notifications, there's a whole bunch of services that will run an app on your iPhone and provide you an API for pushing notifications. And then, of course, if you were inclined, you could try to become an Apple developer and do your own custom app of some sort. So I looked at pushover.net. You can download the app for free and start a 30-day free trial. At some point, if you like it, you can pay them $4.99. And that's a one-time lifetime fee for that device. And there is no cost for sending the notifications. So that seemed reasonable. And it's pretty simple HTTPS push API. You've got a token associated with the application, which you can get for free. You get a token associated with the user's device, which they spent $5 to get. And then you can send an arbitrary message. There's some other things that you can specify, like what sound to play. There are different levels of urgency. You can violate their do not disturb setting, and it'll play the message even if they're in bed. And then the highest level of urgency, they have to acknowledge the message. If they don't, they get notified again in some number of minutes, 5 minutes or something. And that happens until they ultimately acknowledge the message. But again, that's all programmable from the post request that you do. So I started thinking, how am I going to power this thing inside of a refrigerator? I don't really want to drill holes in the thing to run some wires. I don't really want to try to tap into the light bulb or the door switch. So probably I'll go with a battery operated device. I have to somehow, I assume, talk to the internet if I'm going to do a HTTP post. Wi-Fi is available where a refrigerator lives. Again, I don't want to drill holes inside for serial out or Ethernet out.
What sort of fridge is this? Is this a medical?
It's not an ultra cold.
Metal. It's not, but it's not. Is it like a lab?
No, it's a home. It's a residential. I will get to my concerns about a big metal box being a Faraday cage in a minute.
Got it.
So this is kind of my go-to device for battery-powered, Wi-Fi connected Arduino devices. This is the D1 Mini Pro, and so it has a JST connector down here that you can plug a LiPo battery in, and it has a charging circuit. It recharges off the USB port if it's plugged in. It's $5.
The new version of the ESP8266 has a built-in temperature sensor.
The new version. I didn't know there was a new version.
There's a new version they have. I don't know that it's available yet. It's just basically more like the 32. However, it's only one CPU and has I noticed a built-in temperature sensor.
Okay, cool. That would be useful. So in the past, I have developed a shield for these D1 Mini devices. This one is one I did. It has a one-wire interface. It's also for my rain gauge, so it's got some other pins that I don't need. It's got a little piezo buzzer and a push-button switch for user input. I've published it on OshPark. This is just over a square inch, so 3 of them cost $6 or $6.60 or something. So here's when we talk about Faraday. I was concerned, is a refrigerator a good Faraday cage? Nope, I had no problem at all getting to my Wi-Fi. The seal around the door must be wider than lambda over 20, right, Kevin?
Were you able to answer the question of whether the light bulb goes out when you get into the refrigerator?
No.
Oh, okay.
I don't have a light sensor on it.
Okay, so you didn't get in the refrigerator.
No.
Okay, just checking.
Okay. And then another concern I have is, how do we know it's working? If things are going well, the temperature limit is never exceeded, and the device never does anything.
It could send you something.
It could send me something. And so then, feature creep, right? Well, let's check for too cold. Instead of delaying for Y seconds, we can deep sleep, save battery. If we've got a battery, we better check for low battery voltage and send some kind of notification before the battery gets so low that we can't send a notification. And then it'd be nice to send something once a day to let you know that things are working, and some kind of a summary of the range of temperatures seen, and the Wi-Fi connection, the received single strength indicator, things like that. I've got a beeper. I may as well beep every Y seconds so that we can maybe tell that things are going on.
If that doesn't drive people crazy.
Yeah, they may not want that, so beeping may be not beeping may be an option.
You could beep when there's a problem, though.
But wait a minute. Isn't the beep inside the refrigerator?
It is, but you can hear it.
Yeah, but if the door is open, the beeping could be a signal that, hey, got somebody close the door.
Absolutely. But you can hear it through the closed door as well. So, and then my daughter said, well, if you're going to make one of these, can you make 3? I'd like to put, so she works for a mobile large animal vet, and they have a refrigerator with vaccines and things at home base, which is the one that they were having issues with. But they also have refrigerators in the trucks that go out. And if you forget to plug the truck in when it comes home at night, the refrigerator warms up. And I guess they run on batteries during the day. Once the battery runs down, the refrigerator warms up. And so she wanted 3 of them. And I said, okay, well, we're going to need some kind of a ID per device so that when you get a message, you can know which device it is that's complaining. And then they're going to want to change the set points. You know, they're going to start getting false positives. If they set it to 46 degrees, they're going to open the door and get something out and close it, and it's going to go to 47, and they're going to get a thing. And so it'd be nice if she could change some of these settings without having to learn how to run the Arduino IDE and edit the code and recompile and download. So these are the things that I decided to allow end user customization. The temperature limits, the low battery voltage, the Wi-Fi, SSID and passphrase, you're going to need that. The token of the device to send the pushover notices to. How long Y is, how long it should sleep between waking up. The device ID, some kind of a timing adjustment. These things, when they're asleep, they have some kind of a crystal oscillator inside of them that roughly keeps time, but it's not going to be totally accurate, so I may need to tweak the timing a little bit. How long the beep should last, when you go, whether you go beep or beep, And then I also put in a couple of flags. One, the phone home flag sends the daily summary not only to her phone, but also to my phone, so I can keep track of what's going on. And then a USB powered flag. We'll get to that in a little bit. So now the code looks a little bit more like this. So I don't know if you know when the ESP chips go into deep sleep, when AVR chips go into deep sleep, when they wake up, the PC is preserved and they start executing on the next instruction. That's not the way ESP chips work. They essentially do a reboot. So they start up from scratch. And so if when you wake up, the push button on the shield is being pressed, then I go into this mode where I bring up a web server, set the device as an access point, service up a little page that has all these settings that you can connect to it with your cell phone, navigate in your browser to 192.168.4.1 and see the web page, change some things, and save the settings and have it reboot. So if the switch is not pressed, then it goes into its normal mode. It does a little beep. It checks to see whether it should send the daily notice, checks the temperatures, checks the battery voltage, sends appropriate notices. Deep sleep for 6 seconds.
I would probably use an IP address that's higher, 168.192. Like, who knows, 100 or something, because you don't want to interfere with any local Wi-Fi.
So the ESP8266 is acting as...
It's acting as the server, right?
That's correct. And so
you have the passcode.
You connect the Wi-Fi to it. It's open, so you don't need a passphrase. And it has total control of all the IP addresses on its network. And the default in the library code is .4.1.
Well, but what if you're running this in a house or in a building that has Wi-Fi at 192.168.1?
Yes, the SSID will be different.
Right, you're connecting to a different access point. So we're connecting to this device itself, right? It serves up, the SSID is whatever I want it to be. So it's CTD underscore whatever the device ID is. And so you go to your cell phone and you go to settings and you go to Wi-Fi and you look for the thing called CTD underscore A and you connect to that and then you browse to 192.168.4.1. So I don't think that's a problem.
It's a strange consideration, but if you put a resistor divider on the battery pin going to one of the A to D pins, that actually is a major current drain on the battery. There are some interesting chips that will let you switch that in and out, but monitoring battery voltage is a little trickier than just a resistor divider.
So there is on the back of the D1 Mini Pro, there is a solder jumper which connects the battery voltage to the resistor divider network required, that hooks it up to the one analog pin that the ESP8266 has.
And that will draw I mean, if you're dealing with like 50 microamps of current, 25 microamps of current, then that resistor divider becomes a significant part of your equation.
Yep. Is that, is it still active even when you're in deep sleep? I think it's not.
Well, if it's a resistor divider, then there are some switches. There are some analog switches which are designed to switch the battery voltage in and out, but
Yeah.
there's no real way of making it inactive. If it's checking the battery voltage and it's simply a passive divider, then
Okay.
then that's what it is.
Yep. You are correct. So that's a drain on the battery.
So there are a couple of chips I've looked at which you might want to add to your board. I can send you.
Well, you could take the ground end of your divider and hook it up to an I/O pin and ground that pin when you want to do your voltage dividing. Otherwise, let it float.
And if you let it float, it will go above 3.3 volts because that's where the battery is, and you'll blow the pin.
Okay. Maybe I believe that.
I've done it, been there. You can play some games with diodes and get around it, but just be very careful about taking any of the analog pins. The analog pins are designed to be between 0 and 1 volt, and
Yep.
be very careful of taking.
There's only one.
Yeah, be very careful of taking them too high.
Okay.
You'll SCR there's a parasitic SCR on the diode protection diode, which will hurt you.
Okay. That's a good point. And so here's my little prototype. There's the D1 Mini, my LiPo battery, a notice. If you buy these, well, wherever you buy these from, there are two standards. In other words, there's no standard as to which pin is plus and which pin is minus.
I've noticed that.
Yeah.
And they don't like being reversed.
Nope.
So I had to switch. I bought these from Amazon. I think they're designed for drones. And the polarity was wrong. So I had to pull the pins out and switch them and put it back in. There's a little plus sign there on the D1 Mini Pro. So that tells you where the red wire is supposed to go. Here is my shield with my temperature sensor probe screwed in. For the ones I made for her, I didn't populate all of these. I just did the 3 there. I could have just soldered them. A little speaker, my push button. There's a little resistor I put on here. We can talk about that later. And then I made cut a little piece of cardboard that I placed on top of the battery so that the pins sticking through don't scratch through the case and start a fire. So I laser cut a little box. I put a hole in here. A little bit of thermal isolation, I think, is probably a good thing for this device. You don't want a waft of warm air coming in as you open and close the door, setting the device off. The vaccines they're trying to protect some of them are in cardboard boxes. Most of them are in aqueous solutions that don't warm up nearly as fast as
Typically,
air
you would
does.
use. Typically, you'd use two sensors, one in a liquid vial and then one in the air.
Okay. This device certainly supports more than one sensor on the one wire, so I could do something like that.
That way you can tell the difference between a door opening versus the vaccine's actually starting to get warm.
Yep.
Let you forecast your response time.
Okay.
Other,
And I posted a link. I was going to say I posted a link in the chat with a full post outlining how to use a PMOSFET to switch in your voltage divider only when you want to take a measurement, so it's out 99.9% of the time.
Oh, cool. So some other issues came up. When you take the device out of the refrigerator to recharge the battery, you don't want to get inundated with hot notifications every 5 seconds, every 5 minutes, or whatever you're doing.
If you monitor pin 0, it will tell you if you're plugged into the USB connector.
Pin 0.
GPIO 0. When you plug it into the USB connector, goes high, I think it is. And when it's unplugged, it goes low.
Well, I will have to look into that.
I just found that out.
I mean, 0 is one of the IOs you can use, though.
Well, it's on the 32. I found that, and yeah, you can use it. It's a soft pull up, but on the 32, I just Sunday was looking at a very similar problem and went through, triggered the LED when I was plugged into the USB, and I can now detect whether I'm running on USB power or not.
Okay.
Just went through that pain. I don't know whether that's the case with the 8266s. It's definitely the case with the 32s.
Okay. So I'll tell you what I did. So I developed this plugged into USB, and my shield actually powers the one wire using the 5-volt, which is either this pin or this pin. But when you're on battery power, there is no 5 volts. And so my one wire wasn't being powered, and I would read back zeros all the time, and it was always 0 degrees. And so I relayed out this board to use the 3.3 volts to power the one wire, which works fine. And while I was doing that, this board's been reworked. I put in a voltage divider network from the +5 pin down to one of the digital I/O pins. And so it reads high when 5 volts is present and reads low when 5 volts is not present. So I can check that to decide whether or not whether we're plugged into USB power or not, and suppress the notifications. That got me to thinking there may be applications, or there may be uses of this device where you actually want to be USB powered rather than battery powered. And so it would be nice to be able to get temperature notices even when you're on USB power. And so that's why that USB powered flag was one of the things that is in the customization. When the refrigerator is warm, I'm happy to send out a notice every 5 minutes saying I'm hot, I'm hot, I'm hot. Please come shut the door. But when the battery runs low, I don't want to say the battery's low, the battery's low, the battery's low, the battery's low, and run down the power even faster, right? So once or twice would be fine. And then the other issue is, how can I tell when it's time to send the daily message? So we talked about this. The USB cable provides 5 volts. So variables in memory don't survive deep sleep. And so if I want to know that I have sent out the battery is low message, I need to remember that across deep sleeps. We could store that in EEPROM. On ESPs, it's actually the flash. They emulate the Arduino EEPROM support using a chunk of flash. But I don't want to write to EEPROM every 5 minutes or every 1 minute or every whatever. I don't want to do it often because I don't want to wear out the flash cells. If it's something that's once a day, yeah, you could probably do that.
Well, write it only when you have sent the message.
Right, but there are other things that I want to keep track of. We'll find that. Yeah, so the battery only runs down probably once every month or two, and so storing that in EEPROM is not at all a problem. But I found out that there is no real-time clock, so we don't know what time it is. But there is something called RTC, real-time clock memory. There's 128 words, and that gets powered during deep sleep. And so we can store, some of that memory gets used by the bootloader code and stuff. I tried writing zeros to everything and then reading it back when I woke up, and 3 or 4 memory locations were non-zero. I tried writing ones to everything and reading it back when I woke up, and maybe 10 or 15 locations had zeros in them, so somebody had cleared them out.
The MAC address is stored there.
The MAC address?
Yes.
Okay, I didn't see anything like a MAC address in any of those.
Okay, no, I'm more familiar with the 32s than I am the 82s, but the MAC address is stored in there's an ID and a MAC address and a couple other things that are stored in the RTC memory.
Okay. But so this was news to me. I mean, this is great. I can store data and keep track of a lot of things across my deep sleep reboot cycles. It doesn't survive power going away and coming back, so it's not like EEPROM. And so there is no real-time clock. When I post a message to pushover, when I'm on the internet, I can find out what time it is. And actually, part of the response that I get back in posting something to pushover includes the date and time in Greenwich Mean Time, but that's okay. And so we know that we're sleeping for approximately Y seconds. And we know how many seconds there are in a day. And so we know how many times we should wake up each day, plus or minus 1 or 2 probably. And so one of the things that I put into RTC memory is a little counter that every time I boot, I increment. And I can clear that counter when I send my daily message and monitor that counter. And when it gets up to this number of 24 times 60 times 60 divided by Y, it's been about 24 hours and I can send my daily message.
And get your time back and reset your time.
Get my time back, do any little tweaking I want to compensate for the, how much I've drifted. And so that's been working pretty good. I post my daily message at midnight Zulu, midnight Greenwich time, which is 8 o'clock, which is currently 8 o'clock our time. It's 7 o'clock during the winter, 8 o'clock during the summer, PM. And so that's been working pretty well. So how do I know if, when I read back my boot count, whether I'm getting a good number or not? And so what I end up doing is storing a magic value in one of the locations. That magic value will not survive a power cycle. And so if I read back the magic value and it's what I expect, then I can assume that the boot count in some other memory location is correct and I can act on it. If it's not there, the magic value, then I go ahead and post a daily notification pushover, get the current time, set up my timing adjustment stuff, and carry on. So how long will the battery last? So if all you do is wake up, check the Dallas one-wire temperature sensor, check the battery voltage, and go back to sleep, that takes less than 1.5 seconds. Most of the time is waiting for the temperature sensor. You have to wait 3/4 of a second for it to capture its temperature value. You don't power up the radio, so it doesn't use a bunch of power. If you have to connect to Wi-Fi and post pushover, it takes about 10 seconds. And there are spikes of use of power up to 400 milliamps. So I did a little study. I sleep for 5 minutes. I wake up. I send a notification. Actually, it was to Adafruit. And the battery voltage. And that ran for about 10 days, waking up and powering up the radio every 5 minutes. So I did a little CEO math. And I said, well, if it ran for 10 seconds every 5 minutes and ran for 10 days, then if I only ran for 1.5 seconds and used even less power, it ought to run for 2 months. We'll see. I will tell you that I have a similar setup running my soil moisture probe out in my driveway, and that's been running for several months, and the battery seems to be still running fine. Now that one, I'm not connecting to Wi-Fi. I'm using what's called ESP Now, which is a proprietary. I'm still powering up the radio, but I'm using some vendor-specific code to talk from one ESP to another with a real lightweight protocol. I can wake up, get the soil resistance, send it on ESP now, and go back to sleep in less than half a second. And so that's been running for months now.
The deep sleep current on an 82 should be about 20 microamps.
The deep sleep?
Yep.
Yeah, that's 19, 20 microamps is what I recall. So that's the end. Any questions or more comments?
One quick comment, let the battery warm up before you recharge it. It's hard on the lithium battery to be charged when it's cold.
Okay.
It'll shorten its lifetime.
Start. Okay, so I have to pull it out of the refrigerator. I don't want it to sit there and warm up because then it'll start sending notifications. But I want the cell to warm up
Presumably,
before I plug in the USB.
I would
And
have 2
it's-
batteries and just swap.
Okay. My daughter might do that.
But I mean, it's just going to shorten the, from what I've read, it will shorten the lifespan of the battery, and it's potentially damaging to charge cold. I don't know I can't tell you the definition of cold though. But
Okay.
presumably a refrigerator would be considered cold.
Mm-hmm. I know that, so I've done some of these voltage studies before, and the voltage that you get out of the LiPo is very temperature sensitive. And so if you want to monitor the voltage accurately and know that it's getting low, having a constant temperature, even a refrigerated constant temperature, is a good thing. But I will check into temperature while charging. You know, if there's 5 volts, I don't have to go to sleep because I know I've got as much power as I want. So I could do something with the... No, I can't. I don't have any control over the onboard charger, I don't think. I think it's going to kick in as soon as it sees power. So I've got to pull it out. I guess I can put it into access point mode.
Pull it out and it'll send you a message when it's warm enough.
Yeah, 47 degrees, which may not be warm enough. Okay, yeah, I don't know. It's a good point. I will look into it. Any other comments?
Nuts and Bolts actually has, and I think it's this month or last month, something very similar with having to do with the refrigerator and temperature. So when you had mentioned this, I think the last time, I go, oh, that's interesting. Nuts and Bolts had an article.
All right.
I don't know how they did it. I didn't actually have a lot of interest in it at the time, but
All right. Well, if you or Scott can find a link to it on me, I don't know if that's something that non-subscribers can view or not.
Yeah, I'm not a subscriber, so yeah, you can get it. I get their monthly, or I don't know if it's monthly or weekly emails. I think it's monthly.
Yeah.
And you can get to various articles, and that's how I originally saw it.
Okay. I'll look into that as well. All right. Anything else? Okay. Thank you. We can go to show and tell. Let us know if you want to be recorded or not. If you don't, we'll turn the recording off. Carl, I think you said you had something?
Yeah, I do.
All right.
So you guys may remember a while ago, I designed this circuit that was a pulse width modulator using op amps. Well, I think I mentioned that I was coming up with a much, much better version, and this one actually is much, much better. So that's the latest and greatest of it. You may be interested in the fabricator I had for this. It's JLC PCB out of Hong Kong. I put in my order on July 22nd, and I got it on the 28th.
Wow.
Phenomenal.
The shipping cost me $12.88. I had just made this larger board, which I showed you a while ago with them, and they gave me this incredible discount for the second board. Matter of fact, the price was the same between 5 or 10, making 5 or 10 boards. So I just went with 10. They charged me $5 to actually make it. And
$5 for 10 boards that big.
This size.
Yeah, we don't.
Here's one unpopulated. I've got this out on my GitHub account. Here, let me quickly share the screen here. So you're probably seeing me now. So this, can you see the?
Yeah.
You can see my GitHub. Okay. So this is a complete definition of what the board does. Calibration for the board is in here. And there's 2 pictures of the front and back.
And so that's about 1.5 inches by 3 inches, something like that.
No, it's not quite that big. So it's like
1 inch by 2 inch.
I do everything in millimeters these days, so I think it was a little
30 millimeters by 50 millimeters.
It's 30 by 74 millimeters. Okay. Actually, 48 by 74 millimeters.
Okay.
Yeah,
that's crazy price.
I was even able to make it black, and I did a couple of other things, and there was no change in the price. So I said, okay, I'll do it. There's the schematic. So I can actually show you. So here's the schematic. So what it is, there's 2 different type of comparators and 1 op amp. And that was the major difference. The other one was completely op amps. And op amps don't do well as comparators, which is what I had been using it for. So this one is actually using one surface mount part, and the other two are through holes. The surface mount is the LM393. It's a dual. The op amp is a CA3240E. That's a dual. That's a through hole. And then the other comparator is an LM311. Now, the LM311 has a floating emitter on the output stage, which means you can lock this thing into whatever voltage you want as an output volt, well, below the rail. So you can lock it into 3.3, or you can lock it into 5, and the PWM will be 0 to 5 or 0 to 3.3. So that's one advantage with this circuit. The other advantage is on the input, which is J3 here, if you see that. So this also allows you 3.3 or 5, but you have to actually adjust that with the two trimmers that you see there, R9 and R11. R11 is the amplification factor. R9 is the zero crossing. So the oscillator is actually in this section, and it's the LM393s, the two of them, and one of the CA3240Es. R1 adjusts the frequency, and R3 here on the lower left on your screen adjusts the internal peak-to-peak voltage. You can tweak R6, which can give you a little better zero crossing. I found it isn't really that necessary because you can kind of compensate for it with these two trimmers down here. So what's happening here is that you're getting a here I could show you the 3D on here. So here's the 3D. That should look very similar to my actual circuit board. You can see that there's a surface mount, and they don't actually show it. There's no 3D image for the footprint. It's the only thing that there's no image for. An interesting thing I found, this is a bipolar power supply. You can see here there's a -12 and a +12. You know that 0.1 capacitor that we always put in to keep out any sort of noise? You need two of them on a bipolar. You need one from the negative and one from the positive on each chip. So that's why you're seeing so many of these caps in here. R1 is actually the oscillator. It's the only cap that's actually doing anything other than dealing with interference on the line.
C1?
Yeah, C1 right here.
Yeah.
So it's a so you can kind of see underneath here. Actually, I'm going to do this. If I kill all the 3D stuff, you can just see the board. So yeah, that's a 0.001 UF. The rest of them are all 0.1s.
Yeah.
And there's one 3906, 2N3906 transistor. So the nice thing about this circuit, yeah, let me put that back on, or it seems to hold that and never, you always have to turn it back on. The nice thing about this circuit is that, here, let me see if I can go back to that, is that it had, so the other circuit that I had, if you adjusted the output voltage, it would change the frequency. And if you adjusted the frequency, it would change the output voltage. It was a real pain in the butt to calibrate.
Yep.
This circuit the way you calibrate it is you set the calibration, the internal voltage, which is R3, to what you want, which is 10 volts generally. And changing, and that will adjust, that will change the frequency. But when you go in to change the frequency, it will not change that voltage, which is perfect. That's exactly what I wanted. So I set that at 10, and then this sweep over here at TP3. So I have that set in the LT spice diagram for 2500 hertz. The frequency of the PWM is 25,000 hertz, and it can go much higher than that if you want. You can also swap out that this one capacitor, C1, and put in a lower value and actually get a higher frequency out of it. And the whole thing is incredibly stable. And it was very, very easy to work on this compared to the old one. Calibration on the scope, I needed a scope and a multimeter to calibrate it. It really didn't even take that long to do it. If this is going to be, I'm going to have 4 of these. They'll be controlling the motors in the robot I'm building, and I will probably put, a drop of like Loctite or something on the trimmers so they don't bounce it around, and the robot doesn't change the calibration. I might not even need it. I don't know. But yeah, this actually, if you want, I can bring up the LT spice diagram, and you can actually see what's happening in there. It's actually kind of cool. Here, I can bring that up pretty quick. Where is it? We got it here. So LT Spice has updated their application yet again. So here's the diagram. And if all I do is click on run, so the square wave, we don't really care too much about. I put a test point on the board for it, but we don't really use it for anything. If I click on this, that gives us the triangle wave, which, believe me, it is this good on the scope. It is excellent compared to the other design. If I then click on my sweep, so that is essentially your voltage control. So you won't actually be putting a sine wave in there. You'll just be changing voltages with a joystick, or the CPU will be determining what it will be, and if it's autonomous. But this is kind of the test arrangement for this. So what you want is your sweep voltage has to have the same zero crossing as the triangle wave. So you don't want it shifted up or shifted down, right? So the actual PWM is there. So you'll notice the PWM is 0 to 5. That's what I've got it set for. I could, for example, put on here, I could change this to 3.3 and then rerun this. Now it's 3.3. So it's really, really handy. I mean, this thing will work on either side with a processor, and you don't have to worry about it. Calibrating the input for, I think I have it calibrated for 3.3 now on the input. Calibrating it is a little bit more difficult than just switching the voltage. So on the actual circuit, there's actually a connector that allows you to put that the voltage on it that you want, and that's how you determine the output voltage. You just apply 5 volts or 3.3 to the connector, and that's what the LM3311 will give you.
So Carl, in your real application,
Mhm.
you said, so maybe you want to run the motor at,
So the H bridge that I have will take a 5-volt pulse modulated signal, and then I hook up the motors to that H bridge, right?
right.
So that handles that side, and then the other side will be run by, I don't know, I think it'll be an ESP32 actually.
So where does that input
That
come
input is the
in?
VC input.
VC.
Here, let's switch back to here. So that's here, that's your voltage. VC means voltage control.
Okay.
Okay, so this says 3.3 or 5. So we're back to the KiCad drawing here.
Yeah, yeah.
So we've got a ground, and so ground on pin 1, and then pin 2 would be where the CPU would be connected to.
Right. So the CPU says I want to run. It's a 12-volt motor, so I want to run the motor at 12 volts, but I want to PWM it at 50%.
Right. So you put half of 5 volts on there.
So you put 2.5 volts
2.5
in there.
On these 2 pins.
Okay.
And you will get exactly 50% coming out of the PWM out.
Okay.
But you can see that though in this diagram. All right.
I see the sweep, but
This
the sweep seemed to be on the output, and I didn't know where.
no, it's
That
not
was
on
coming.
it's an internal connection that says sweep is TP3.
Right.
So what I do is I take the oscillator, I put it into another comparator on the inverting side, and then the non-inverting side has the sweep on it. When you combine the two, you get a PWM.
Right.
And then because this one allows me to shift around the
Right. In this simulation, you're putting a sine wave in on VC or something, right?
right. So that would be in lieu of the CPU.
Yeah. Okay.
Right. So at 50%, we're about here. We're in this section.
Yeah.
Okay. So we're getting close to 50% in here.
Right. Yeah. I just didn't know where it looked like that sine wave was an output.
No. The only output is the red line on this.
Well,
The blue line.
The sweep TP3 test point, right? Is the blue line.
Right.
And that's a sine wave, and I didn't understand how it was being generated.
Okay, so
evidently you're feeding a sine wave into VC.
Yeah. Okay, so you see down here where it says V3 on the bottom, there's a round circle on the bottom left. Okay, there's VC.
So
that's a voltage source.
Okay.
That's a voltage source, which I have set up to create a sine wave,
right.
And the frequency is 2500. And
okay.
you can see I have 1.65, 1.65, which is half of 3.3. So that tells me where the crossover point will be. So I'm sticking it right in the middle. Okay.
Yep. Okay. I understand now. Thanks.
And then this here, this op amp here. So this is an op amp. It's the other half of the one in the oscillator. This one actually amplifies that signal so that it is the same amplitude as the triangle wave.
Right.
And that's why you have to do the adjustments on R9 or R11, depending on your incoming voltage, because the amplitude is going to change. You have to readjust it for a different voltage. But you're not going to be doing that all the time. You're going to set this up for your environment, lock it in.
Right.
So that's what I've been working on here. And you guys might want to look into this company. I have 3 boards made from them so far, and they've all been great. I've had no problems. And their turnaround time this last time was just amazing. I don't think I could have gotten it from OS Park that fast.
Yeah, I'm sure. I had pretty good turnaround on my last board. It took shipping, I think, was 3 days from Oregon, which is much better than it was during the pandemic and the
Right.
USPS slowdown, shutdown, whatevers.
Yeah, the one that I did, that's the battery pack. This one took a lot longer to come because it was, I think I did that one like in March or April, and that took a lot longer. Of course, it's a bigger board. It also probably took longer to manufacture.
Okay, anybody else have show and tell? All right, well, we've got a little time. I'm going to bring up something, my next big project. I'm almost done with the manure spreader. Still waiting on a tire. It has a flat tire courtesy of one of the other manure spreaders. We stole the good tire off the one I'm restoring. So you may recall we had a problem of the month where I wanted to level the indoor arena.
Oh yeah, I remember that. You wanted to put a camera in there, right?
Well, that was the thing, was how could I do that, right? And so this is what I'm building. This is a blade that gets pulled behind some sort of device. Might be a lawnmower tractor, might be a golf cart, might be a ATV, might be a real tractor. And the green blade there is going to dig into the sand a little bit. The wheels, so this linkage here between the cyan at the top and the magenta at the bottom is a linear actuator. So here it is without the blade. And that moves the wheels up and down, which...
Was it hydraulic?
It's not hydraulic, it's electric. But so as this extends, it pulls the blade up, and as it retracts, it lets the blade down. Where is ground?
Oh, you're using OpenCAD. That's interesting.
I use OpenSCAD. So you can see that I have plenty of range of the blade above the ground and below the ground. I don't expect to be digging that deeply. It was quite a trick to get all the... So the constraints here are that the tongue has to stay in the same spot and that the wheels have to stay on the ground. And this guy gets longer and shorter, which bends all these other things. And
The actuator, is that something you bought or you built yourself?
it is something I bought. I bought it from Amazon. Let's see if I can find. So it was $310 on sale for $262. It 4-inch. No, I didn't buy the 4-inch. 233. So it'll push 2,000 pounds. It will hold 4,000 pounds statically. So it's pretty hefty. It's got a 14-inch throw. The other throws, longer and shorter, are more expensive. Although this one now, this is a new deal that I didn't, is cheaper. I might have gone with a 4-inch throw.
So that throw does that directly translate to how far the blade is either in the sand or soil or above it?
It does not.
Okay.
There are triangles that.
Right.
This is the hypotenuse of a triangle that.
So what have you actually calculated it to be? Or have you actually seen it do it?
I have not run it yet. If you recall the image here, so I have run this up and down, and that works fine. But there's no blade on this at the moment.
Well, you wouldn't need the blade to know how far it's moving it up and down, right? Because that frame is connected to the blade.
Right. Yeah. I mean, no, you can see the blade is 6 inches tall, and the hole in the center is 3 inches. And when it starts off, that hole is submerged, so it's going down about 3 inches below the soil. I don't expect to ever cut more than a half an inch. And I don't think that it would actually go down 3 inches. I think what would happen is that the wheels would lift up off the ground and the blade would ride along. So the next step is to figure out how to figure out my altitude and decide whether the blade needs to go up or down. When I'm in a shallow spot, the blade wants to be up. And when I'm in a mound, the blade wants to go down.
How are you going to do that? Are you actually going to put some electronics in here to determine that?
That's the plan. I'm still working on that, thinking of doing laser levels. And having, so maybe I'll have a laser level that shines across the arena floor and a white plastic pipe sticking up off the top of this or something, and with a camera looking at it to see the laser line and decide whether the blade needs to be lifted or dropped.
What are you going to use this area for?
It's a horse ring that they ride around every day.
You might take a look at some of the altimeter chips, which are pretty accurate.
Half an inch?
Working with them in terms of water depth, the one I'm using is 17 bits. I'll take a look at the one that I have. They're incredibly accurate.
Huh.
I'd have to do the. It would be worth at least taking a look at.
Okay. So yeah, send me some information if you.
Yeah. It's
17 bit.
I have a bunch of them, and I'm working. I'm working with water depth particularly, and I can detect, change in water depth equivalent to about 1/100th of an inch.
Cool. That would be useful if I could figure out what the accuracy is. I don't need a 1/2 inch. I'd
But that's
probably take an inch.
That's water depth, which is water's. I'd have to look at the numbers carefully.
So let's see. 32 feet of water is the same as an atmosphere's depth of air.
Mm-hmm.
How deep is the atmosphere? 60,000 feet.
Like if I can detect 1/100th of an inch of water, and that's in the hyper accurate mode. I'm not sure it would work, but it would be at least interesting to take a look at.
Yep. Okay. Yeah, I'll, if you have a pointer to one of these, let me know.
Yeah, it's
BMT 180. Okay, I'll look into that.